One more thing to mention before we leave this example is that just like data variables or member variables declared inside a class, member functions also recognize whether they can be accessed outside of this class. So normally if we want to use function add outside of the scope of the date class, we have to make sure that it's publicly available. So private and public are access modifiers which allow parts of the class to be visible or invisible outside of the scope of the class. And whenever I say scope, it means that from the opening brace to the closing brace. So basically we say that class date has a scope which starts here and ends over here. Likewise, function main has a body which the scope of the body of function main begins with an opening brace and ends with a closing brace. Now notice that the function in C++ does not have to basically just ends with the closing brace. However, the class declaration must end with the semicolon, and this is because C++ compiler has to be able to recognize that this is declaration of the new data type, user-defined data type, and it helps the compiler to distinguish that this is a declaration by finding this semicolon. Recall that earlier we talked about this diagram which demonstrated the use of procedural programming structure of a program where the operating system invoked function main, which in turn invoked other functions in turn, and eventually the function returned back at the end of the sequence, returned back to the operating system, and the program stopped executing. In my mind, function main represents the entire application, and so whenever the function is invoked, something happens. This is the timeline of events, and at the end of its life cycle, main returns back to its caller, and this means that our program is now over. We return back to the operating system. Here, I changed this diagram to show that there is a possibility to make our functions, to make them member functions of a certain class. For instance, I could declare main app, the class that represents the functionality of the entire application, and give it function get user input, print report, which were present in our previous diagram, but this time I made them member function. So what changed here is now our main function is creating object some object of this data type, and first it creates a copy of it. Basically this is similar to what we did with the date right here. So this is the object creation. In diagrams it's very typical to show creation of object by saying new. So basically construction of the new object is the call to its constructor, and normally we invoke a constructor of an object, which we'll be talking about in the future. But for now, in the diagram, whenever you will see new, it means that there is a function which creates a new object. So object lifecycle starts at this stage, and apparently from this point on, main function will have an instance, a copy of this object. You can see here, next thing, I'm trying to show you that we can now put user input functionality inside a member function named getUserInput and place it inside the object as opposed to a global function. Likewise, print report now is also kept hidden inside the object. So now, in order to be able to execute these steps, getUserInput or print report, we have to have an object and start making calls into member functions of this object. Another example of a system using objects is shown on this diagram. So let's take a look at what this diagram is trying to show us. So apparently in this system we have two different classes. One is called heater and another one is called thermostat. So heater and thermostat are two classes that exist in the system, and when the main function starts, it creates a copy of a heater. Right? So we said that whenever we see new, the meaning of new is creation of an object in our timeline. So right here we construct an object named heater, and this return line from this call into a function that creates this object returns a variable named heater. So the heater is now the actual name of an object. So apparently the class starts with an uppercase character, and the name of the variable is starting with lowercase, all lowercase characters. Likewise, we also create thermostat in the next step. But notice that this time new takes a parameter which is the heater. So apparently the thermostat wants to be able to access heater in this application. So when we construct the thermostat, so the copy of this object or instance is created, we pass the heater as a parameter, and from this point on the thermostat will probably remember the existence of the heater and be able to communicate to it. So the next step in our main function is a call into thermostat which says set heating temperature. So apparently set heating temperature is a member function of this class, and we begin to run it. So apparently set heating temperature takes a parameter that specifies the desired temperature. In its own turn, apparently in the case of execution of this program, the thermostat decides that in order to be able to accept this heating temperature, it needs to turn on the heater. So you see how here the next step that we execute part of this demonstration is that the thermostat makes a call into the heater part of setting the heating temperature. And so we can observe the sequence of all the interactions, and this time we see that we start in the main function, construct two objects in a timely manner shown here, and then we start using them. So first we call set heating temperature from main to the thermostat. This is a member function of the thermostat, and the thermostat in its own turn, because it has access to the heater, commands the heater to turn on.